In example 1, we have log base 3 of 5. So what we're going to do is apply the change of base into this example. Now here I have two set up, one for log and one for natural log. Again, I said before that the change of base can apply not just to log, but also ln. So when we're changing the base, we're going to put log of 5 divided by log of 3. So whatever you have in the example inside the parenthesis will go as the numerator, and then what you have as the base will go in as the denominator. Now here there's no base, doesn't mean it's not there. In this example it just means an invisible base of 10. So log base 10 of 5 divided by log base 10 of 3. So if you don't see it in your calculator, don't worry, it's just an invisible 10. Now natural log, you can apply the same thing. So instead of log, it just be ln, and then what you have inside the parenthesis will go first in the numerator, and then divided by ln of what's your base, which is 3, in your denominator. And ln is the same thing as log base e of 5 divided by log base e of 3. So again, if you type in ln of 5 divided by ln of 3, you will get the same answer as if you put in log or log base 10 of 5 divided by log base 10 of 3. Again, these two, which form you have, you will get the same answer. Example 2, we have log base 1/3 of 7. So we're going to write the change of base. First off is, when we have something like this, whatever inside the parenthesis or of log, we're going to write as the numerator. So log of 7. And then what we have as the base, in this case 1/3, you're going to write it as the denominator. So log of 1/3. And then just like how I said before, this log has an invisible base 10. So you can still type this in the calculator, but just for show, this is just log base 10 of 7 divided by log base 10 of 1/3. Now for natural log ln, it's the same thing. Whatever inside the parenthesis or of log, it would just be ln of 7 divided by whatever the base is for the example. So 1/3. So ln of 1/3. So that's all it is. Alright, in example 3 we have log base 5 of 6 to the x power equals 9. Now, if I were to write this in exponential form, so my base is 5 to the power of 9 equal 6 to the power of x. Now looking at it, well, we know that it's two different bases on both sides. That's going to be hard to work with, and in order to solve for the exponent. Now if it was the same base, then we can go from there. But in this case, we don't. So simply plugging in log base 5 of 6 to the x power equals 9 into the calculator will not do anything. It'll just freeze up or error or unknown. So what we're going to do is use change of base, including the three properties, product, quotient, and power property, where we can hopefully isolate x, meaning solve for x, and then whatever you have, you can simply type it into the calculator and you see y. So we're going to say we solve for x. So first I'm going to use change your base because we have a base of 5. And most calculators are pre-programmed with a base of 10 or e. So doing change of base will allow us to have log base of 10, which is invisible, so 6x in the numerator, and then log of 5 equals 9. So doing that, change your base will allow you to have logs with base of 10, which that will give us a head start, or the first step, into typing in and plugging into the calculator. Now here I have 2 logs on the left side. That's a fraction. So this is division. What I'm going to do is I'm going to do the opposite, multiply both sides by the denominator, so that I will change this into where it's not a fraction anymore. So just like with regular numbers, I'm going to multiply both sides by the denominator. So I'm going to multiply by log 5 on the left, and then multiply log 5 on the right side. Now, on the left side, once you have log 5 times log of 6 to the power of x divided by log 5, this will end up where it's going to be log 5 divided by log 5, which becomes 1. And then 1 times the numerator will be simply log of 6 to the power of x on the left side. And then on the right side, it will be simply 9 log of 5. And then the only thing I could do here, I can't use product, there's no plus, and there's no multiplication, but I can use the power property. The reason I can use the power property is because x is an exponent, and then with power property I can move x in front of the log. So it's going to be x log of 6 equal 9 log of 5. And I'm going to write up here for more space. So x log of 6 equal 9 log of 5. And then we're one step closer to getting x by itself. So what I'm going to do, since this is multiplication, x times log of 6, I'm going to divide both sides by log 6. And again, this won't cancel out, it just simply become 1. So I'm going to write it what it looked like. So log 6 divided by log 6 is just simply 1. And then I didn't do it to the x, so I'm just going to bring it down. Now we have on the right side 9 log of 5 divided by log of 6. And then again, if we look at the left side, x times 1 is just simply x. And then I didn't do anything to the right side, so it's just going to be the same. 9 log of 5 divided by log of 6. So now we've got x by itself. And then once you get x by itself, you can just simply type this into the calculator. But right now we're going to focus on how to set it up, because typing into the calculator would just take less than a minute, as long as it was done correctly. So again, x equals 9 log 5 over log of 6. And that's how you're going to use change your base. You're going to use the quotient property, the power property, the product property. In this example, we use change your base, and then I multiply both sides by log 5, to get log 6 to the power of x by itself. And then here I use the power property to move x in front of log. And then over here, I divide both sides by log 6 to get x by itself. So again, the only property I use is change your base, the power property, and then that's pretty much it. Now, some cases you have to use all four: change your base, product property, quotient property, and power property. But in this case, we only use change your base and power property. Alright, in example 4, we have log base 7 of 2 to the m power equals 3. So if I were to write this in exponential form, it would look like 7, that's our base, to the third power equals 2m. So again, we have two different bases. That means it's going to be hard to solve for the exponent if we have two different bases. So what we're going to do is, just like in the previous example, we're going to use change of base. So we're solving for m, meaning get m by itself. So what we're going to do is first apply change your base into this example. So what's going to be in the numerator is log of 2 to the m power divided by log of 7 equals to 3. Now, since I have two logs and I just want log 2m to be by itself on the left, I'm going to multiply both sides by log of 7, log of 7. Instead of doing so, alright, I'm going to show you what it looks like. So this log 7 divided by log 7 will be simply just be 1 times the numerator, which is log 2m to the power of m equals, and I'm multiplying this, so it's going to be 3 log of 7. And then 1 times log of 2m will be just log of 2m equals 3 log of 7. Alright, so now we have log of 2m by itself. So what I'm going to do is I'm going to bring up here, since we're running out of space. So log of 2 to the power of m equals 3 log of 7. Now, I can't use the product property nor the quotient. There's no multiplication, there's no division, there's no subtraction, there's no addition. But I can use the power property because the m is an exponent and it's a variable, so that's going to help a lot. So I'm just going to move m in front of log. That's the power property. Now it's going to be m times log of 2 equal 3 log of 7. And then after that, we're almost done because we have m right here, not as an exponent but as now as a whole variable. I'm going to divide both sides by log 2 So again, when we divide by what we have here, log 2 divided by log 2, that's simply just going to become 1. So we have m, because I haven't done anything to the m, times 1. The 1 came from log 2 divided by log 2. And then on the right side, it would be the numerator, 3 log of 7 divided by log of 2. And again, m times 1 is just simply just going to be m equal the numerator. I haven't done anything to the right side, so 3 log of 7 divided by log of 2. So once you get n by itself, or the variable that you're looking for, you simply just going to type in 3 log 7. Now keep in mind, I have a 3 log 7. So what I'm going to do, if I were to type this in the calculator, I would put parenthesis on it in the calculator. So parenthesis 3 log 7 close parenthesis. Now keep in mind I have two set of parentheses. And then I do divide by log 2. So this is our answer. So again, when you're typing in calculators, if you have multiple things, like for example, in our numerator, we have 3 times log of 7, it's always best to put another set of parentheses. So, parenthesis 3 times log of 7, and then close parenthesis, divided by log of 2. It's always best to group things together when you're typing into the calculator.